Now let's graph rational functions without using a calculator. Let's use the knowledge about the vertical asymptotes, horizontal asymptotes, and x-intercepts, maybe additionally y-intercepts. Now suppose we want to graph this function, and let's figure out the vertical asymptote. We know that this one has a vertical asymptote at x equals to -2 and x equals to 2, where those are the two values where it doesn't belong to the domain of that function. The horizontal asymptote, we know this is the proper rational function. The denominator degree is more than the numerator degree, so the horizontal asymptote is just the x-axis. Now these are the two vertical asymptotes at -2 and 2, and the horizontal asymptote is the x-axis or y equal to 0. And what about x-intercepts? This graph, the numerator is not going to be 0. There's no x value that make numerator 0, so there is no x-intercept. Now let's start to think to graph this. Now we know the y equal to 0, this line is the horizontal asymptote. Now let's think about as x approaches infinity. So as x approaches infinity, the graph either it's going to approach 0, so it will be either like this or below x-axis or above x-axis. So which one is correct? Now as x approaches to big negative number, x squared is still a positive number. So big positive number -4 is still a positive number. So 1 over positive number is a positive. So it is approach 0, but it is positive, mean it is above the x-axis. So now we figure out the graph is going to be above the x-axis. And since the graph has no x-intercepts and this y equal to -2 is a vertical asymptote, there's only one way it can happen, is the graph has to go like this all the way up. And the same thing happens when x approaches positive infinity. When x positive infinity, which is squared, is positive, and that whole thing is going to be still positive. So therefore it's going to be like this. And again, there is no x-intercept, mean this has to be like this. Now what about the from -2 to 2? Now let me write this one. That part is little difficult to understand, so let's try to factor this. X squared minus 4 is actually x plus 2 times x minus 2. Now we have done before -2, just after -2, a value after -2, say we are going to use, say, x equal to -1.9. If I use that, what I get here? So this will be a positive number, and if this is a -1.9 and this is negative, the total is negative. So negative times positive is a negative number, so 1 over negative number. So the whole thing is a negative number, so that means it has to go over here. And when it is just below 2, are we going to use, say, 1.9? If I use 1.9, this is positive. 1.9 minus 2, which is negative. So that means the graph will go over here. Now, where it's going to cut y-axis, we know there's no x-intercepts, so it's going to turn somewhere over here. But we can find f of 0, which is the y-intercept. F of 0 for this function is 1 over -4, x equal to 0. So this is -1/4. So clearly the graph is go all the way up and turn right here. So we really don't need a calculator to graph rational functions. We can use this, the vertical asymptote, horizontal asymptote, x-intercepts, and y-intercept. We can use the knowledge about this to graph them. Now let me show you how to graph using the calculator. Y equal and enter the formula. Formula is 1 over x squared, x, you could use squared for this one, minus 4. And then let's go to window. We have a standard window over here, negative 10 to 10, scale 1, and y value is negative 10 to 10. That's good. And now let's graph it. See what we get. Now we can see we got the graph similar to that we sketched earlier. And if you want to see a little bit better over here, we can reduce the window. Say I'm going to take it from negative 5 to 5, and y value also change from negative 5 to 5, especially since I need to know where the y-intercept is. Let me even reduce this to negative 2 and see what I get. You can see it's cut over here, so we got earlier negative 1/4 as y-intercept. So we use the calculator to confirm that the sketch that we got of the rational function is correct. Example number 2. Now let's graph this rational function again using vertical asymptotes, x-intercepts, horizontal asymptotes, and y-intercept. Now the vertical asymptote, given when the denominator values are 0, so clearly vertical asymptotes are x equal to negative 2 and x equals to 2. So the horizontal asymptotes, so the degree of the denominator is higher than the degree of the numerator. Numerator degree is 1, the denominator degree is 2. So therefore the horizontal asymptote is the x-axis, or y equal to 0. So here are the vertical asymptote, negative 2 and 2. The horizontal asymptote again, same thing, y equal to 0. The x-intercepts give by the px equal to 0. So px equal to 0 when x equal to 0, clearly here. So that means x-intercept is at 0. Oh, right, this point is the x-intercept, mean that graph is going to cross or touch that point. Now let's try to graph this. So we know that the horizontal asymptotes are the x-axis. So now as x goes to negative infinity, a big negative number, we want to know whether it approaches 0 from above the x-axis or below the x-axis. Now when x is a big negative number squared is still a positive number. That minus 4 is a positive number. So the bottom part is a positive number. But when x goes to big negative number, the numerator is a negative number. So the overall, this is a negative number. So that's what we get. It approaches 0 or like this, the below x-axis. Now since the x-intercept is only at 0, so between negative infinity to negative 2, this is not going to cross the x-axis. So that means the graph is going to be like this. And now it's same thing over here. As x approaches a positive infinity, what we see here, this is going to be a positive number, and minus 4, which is a positive. As x approaches positive infinity, this is also positive. So positive or positive is a positive number. So it's going to approach 0 like this over here, above the x-axis. And again, between 2 to infinity, we don't have any x-intercept. So your graph is going to be like this. Just to figure out this vertical asymptote just after the negative 2 and just before 2, we can factor this actually. We can get x plus 2 times x minus 2 like earlier. and I'm going to use, now suppose I want just before 2, what is the value of this? So I'm going to use say x equal to 1.9, for example. If I use that, the numerator is 1.9, which is positive. The denominator 1.9 plus 2, which is a positive number, and 1.9 minus 2, which is a negative number. So overall this is going to be a negative number, mean it's going to go over here. Now to find just after negative 2, let's use a number, say x equal to a negative 1.9. So that means the numerator is a negative number, and denominator, this negative 1.9 plus 2, which is a positive number, and negative 1.9 minus 2, also negative number. So overall we get a positive number. That means it ends over here. Now x equal to 0 is a x-intercept, so our graph will looks like this. Now let's use the calculator to graph it and see whether we get the same graph. So our graph is going to be x over x squared minus 4, and the window, let's change a little bit. We have negative 5 to 5 and scale 1, and let's change y minimum to negative 5. Now if I graph it, so here that is the horizontal asymptote, and then you got a vertical asymptote over here. The graph goes down and then come from there. X-intercept is 0 and go down all the way, and that's a asymptote at 2, and then the graph. So this is exactly the graph that we sketch. Example 3, for this rational function, let's find these vertical asymptotes, horizontal asymptotes, x-intercepts and y-intercept, and then use a calculator to graph it and confirm what we get over here. Now again, vertical asymptote is given when the denominator equal to 0. So to find the vertical asymptote, we need to solve this one. Now we can see we can factor this one, which is x factors of negative 3, which will add after 2, is plus 3 and minus 1. So that gives us x equal to negative 3 and x equals to 1. So the domain of this function is all real numbers except these two. So they are the vertical asymptote at negative 3 and 1. Horizontal asymptote. Now the degree of the numerator polynomial is 2, and degree of the denominator polynomial also 2. So the horizontal asymptote is given then y equal to the leading coefficient of the numerator over the leading coefficient of the denominator. So the leading coefficient of the numerator term is 3, and the leading coefficient of denominator is 1. So that means we should have a horizontal asymptote at y equal to 3. Now x-intercepts. To find x-intercepts are given by when the px equal to the numerator equal to 0. Here we have 3x squared minus 12 equal to 0. So 3x squared equal to 12. X squared, 3 cancel out. X squared equal to 4. That will give you x equal to plus or minus 2. So we're going to have two x-intercepts. One is at negative 2. The other one is at 2, because negative 2 and 2 are in the domain. So the domain is here all x except negative 3 and 1. Since negative 2 and 2 are in the domain, they're going to be x-intercepts. Y-intercepts give by f of 0. So if you substitute 0 here, you get negative 12 over negative 3, which is clearly a 4. Now let's use a calculator to see whether we get these things. Now here I enter the formula 3x squared minus 12 over x squared plus 2x minus 3. Now I change the window a little bit, so we will be able to see the whole graph, negative 10 to 10, in both direction. Now you can see here 1 2 3, you have horizontal asymptote at 3, the y equal to 3, so this is a horizontal asymptote, and there's a vertical asymptote at -3 and also at 1, so this has to go all the way up, and the y x equals to 1 has to be vertical asymptote, and then again this will level up to y value of 3 at horizontal asymptote, and there are two x-intercepts at -2 and 2. Actually the y-intercept negative, this has to be 4. That's a mistake, as you see 12 over 3, that has to be 4, so that's a y-intercept at 4, 1 2 3 4.